Now we have looked at the quantum adjustment. It gives us a way to resolve this paradox here. So in the paradox, we're talking about the risk-neutral process like this. And when we convert it to 1 over s, and we look at the process, there's an extra term here. Now, the key to resolve the paradox is that there's no, we don't have like the risk-neutral process. When you have a risk-neutral process, there's always some numeric asset that's sort of underlying there. There's a that's consistent with this risk-free process. And in this process here, ds equal to ry minus rx as dt plus sigma s dz. Since s is defined as units of currency y per unit of currency x, basically we have used the money market account in currency y as the numeraire, because we're basically expressing the per dollar value of x in currency y. So all this is actually expressed in terms of how many currency y's, right? The number of currency y's here. The number here is really the number of currency y. So there's a numeraire asset here, which is a money market account that's denominated in currency y, has been used as a numeraire. Now, if you convert this to 1 over s, and if you still use the same numeraire, which is this money market account in currency y as a numeraire, indeed, you will have this particular value here, okay? And you can get rid of this extra term if you want to change. If you change the numeraire asset to a money market account in currency X. Okay, let's see how we do that. So if instead the money market account in currency X is used as numeraire, the change of numeraire then requires an adjustment. So this adjustment should be in this form, which is very similar to what we have seen before, this form, right? Which is, so the adjustment here rely on this particular factor. So you put it in here, is basically, you see that rho is -1. And because this one is, the one is s, the other one is 1 over s. So, when it's a change, one is increase, the other one is decrease. So rho is -1, and the volatility is the same. So when you put it together, it's basically minus sigma s square. So then if we do this adjustment factor change under the new numeraire, then you will actually be adding this minus sigma s square. So you have this positive sigma square there, then you adjust it by reducing this drift by minus sigma s square, so you'll get rid of this term here. Then you will then recover this typical term that people would think that would take form. But this form will only be true if the money market account in currency X is used as a numeraire. So here in this process, everything is expressed in units of X, how many numbers of X, okay? But if we express this in terms of how many number of the X, but you use a numeraire that is denominated in y, you will have an extra term. This extra term will only disappear if we express this process in numbers of x, and also use the money market account denominated in x as a numeraire asset. Then under that equivalent martingale measures, this process would not have that extra term here. And in this case, if you instead want to look at what's a DS, but you want to keep numeraire asset, you want to use the money market account in currency X as the numeraire asset, then again, your DS term, DS process will have an extra term here. Okay. So if your money market account is consistent, the numeraire asset, which is the money market account here, it's in the same currency as what you express here in units, then you wouldn't have the extra term. But if they're different, that means that if you express something in units of Canadian dollar but use a US money market account, or if you look at a process in terms of units of US dollar but use a Canadian money market account, then in both cases, you will have an extra term there.